So here's the big one, factoring. Factoring is breaking it down, right? Breaking a polynomial down, breaking the polynomial down to the polynomials that would multiply back together to give you what you started with. And there's different types of factoring, and you've done this all already, so hence the reason we're kind of doing them just as a quick review. Common factor, do you agree in number 1, is 5x squared? And then you would be left with 1 plus 5x, and that 1 would be important. What's a common factor in the next one? Between 35 and 60, I bet, is a 5. And then with the variables, you can always do the lowest power, so it would be x cubed y, and then I believe 7y cubed minus 12x, right? Kind of a long common factor one. Looks like the common factor here, I'm thinking that it's 6 for the numbers. Then the lowest power of a is a, and the lowest power of b is b squared. B squared. And then I would be left with 6a what? Squared, right? Plus 11ab minus 6 into 2, 10. I don't know, 35? Is that right? Yeah, 35. So 35b squared. Ta-da. Common factor factoring. Difference of squares, that's a fun one, right? When you have something like 4x squared minus 9, how it's 2x minus 3, and what's the other factor? 2x minus 3, right, 2x plus 3. So if I go underneath to this 16r squared, this is just 4r minus 13, 4r plus 13. Does it matter if you put the plus first or the minus first? It does not. Hidden are like one step harder. So if you look at 2x squared minus 50, it doesn't look like difference of squares, right? But you could pull out a common factor of a, right, 2. So if I pull out the 2, then the difference of squares is like revealed. So 2 is part of my answer still, and then I have x minus 5, x plus 5. Similarly, the one underneath it has a common factor of a 5, and then it's 9x squared minus 16y squared. But that can factor again, 3x minus 4y, 3x plus 4y. All the way, they kind of factor and then factor again. So y to the 4th is y squared times y squared, right? Y squared times y squared minus 1 plus 1. And only one of those breaks down. Which one? Right, y squared minus 1 breaks into y minus 1, y plus 1, but sum of squares does not factor. We'll talk about that more on the homework, but you can, any which way you try it, sum of squares does not factor. Y squared plus 1 just stays there. So similarly, 81x to the 4th is 9x squared, and of course 16 is minus 4 plus 4. Here I put the minus 1 here first, just to show it's not like the first one breaks down or the second one breaks down. It's the one that's the difference of squares breaks down, and the one that's the sum of squares does not break down. So that was difference of squares. Grouping is really extended common factor. Grouping is really extended common factor. You use grouping when you have 4 terms. Now this one you may have forgotten because you don't use this too much. How you do grouping is you group together the first 2 terms, you group together the last 2 terms, you pull a common factor out of each group. So the common factor in the first group is y, left with y plus 3. Y plus 3, come on. Just doesn't want to write it. Y plus 3, there we go, plus common factor in the next group, right, is a 4. 4 times y plus 3. Now, so now we can pull out the common factor group of y plus 3, and we're left with y plus 4. So the common factor group gets pulled out.
He said no.
The next 4 terms here, group. Common factor in the first 2 is y, left with 5y plus 2. And these problems are set up so you will always get the same common factor group. So it's kind of helpful to know. Common factor is 2, 5y plus 2. 5y plus 2 is your common factor group. And then you are left with y plus 2. It's just one to write today. Perfect. The last one I usually change a bit just to make it the harder version where we'd have 2 negatives there. That's really as hard as this one gets. I factor out an a, c plus d. Notice I changed that so I would factor out a negative b and then be left with c plus d. So overall I would get a minus b, c plus d. And you can have these 2 groups in any order. In other words, you could say c plus d, a minus b. All right, onwards we go. Now we get to like normal factoring, what people usually consider factoring. Right? Usually when you think of factoring, you think of trinomials. So a trinomial here, x squared plus 5x plus 6, that's going to factor x plus 3, x plus 2. Right? If I kind of go down the column here, now I got different signs, so I got to be careful. X minus 5, x minus 2, right? Because it's got to multiply to a positive and add to a negative. If I've got, maybe I'm going to go here next to the difficult. By difficult, we mean leading coefficient, right? So the leading coefficient there is 3. That makes things tougher, because it's 3z and z that multiply to 3z squared. And sometimes I put a little bar in my z's so they look different than my 2's. Then I've got a 35, and I gotta be like, oh, what's that? Oh, 7 and 5. But I've got to use the numbers and use the signs in such a way that the inner and outer terms add up to 16. This gives me negative 21, or positive 21 and negative 5, so that works. And it's called trial and error because you literally just try stuff until you get something that works. And sometimes you just get some inspiration, like I just did there, where I see negative 12x and positive 1x. And we know that these are difficult, but this is really the thinking that's needed for this whole course, is being able to unfoil leading coefficient trinomials. A trinomial square is a little easier because it's a perfect square, x minus 5, x minus 5, like that. Or you could say, what, x minus 5 squared. Another leading coefficient one with the 4x, I think this is going to be 4x plus 3 and x plus 1. That's going to work. Like, there's a lot of combinations, but only one combination actually works. The last row are little tougher ones. Maybe, maybe not. I don't know. 4a squared, whenever you see perfect squares, usually kind of makes your life a little easier. This one's going to be 2a minus 3, 2a minus 3. Then I've got a common factor here of an x squared plus 2x minus 35. So I have x times x plus 7, x minus 5. You always want to look for those common factors. Even in one like this, where the common factor is 3x, x squared plus 6x minus... You always want to look for the common factor first. So here I had a common factor of 3x, which I pulled out. And that makes my life so much easier. X plus 8, x minus 2, right? The last thing is the new thing. And so we're kind of tired at this point, but here we have like a whole new thing to learn, which is sum and difference of cubes. And I'm going to give you these 2 formulas, which we eventually have to memorize. And this is how we factor. It's just a pattern of how we factor either the sum of cubes, or here I'm going to show the pattern for the difference of cubes. So there's some similarities, obviously, between these 2 formulas. One thing that I remember is whatever sign starts here, it repeats here, changes here, and then ends positive. Whatever sign is here repeats here, changes here, and ends positive. You basically just have to decide what's your A and what's your B. So if you think about cube roots, right, x times x times x is x cubed, so the cube root of x cubed is x. Similarly, the cube root of 27 is 3. Once I see that minus there, then I'm going to use my minus formula, and I'm literally just going to plug in a minus b, a squared plus ab, that's a 3x plus b squared, or what we call plug and chug. In the next one, a is x and b is 5, because 5 times 5 times 5 is 125. So now I'm using my sum formula. A plus b is x plus 5, a squared minus ab plus b squared. And on the homework, we'll refoil those out and show how they're equivalent. Here we're just kind of doing the answer. The last one's the hardest one because the a here is 2x. 2x times 2x times 2x is 8x cubed. The b is 1. 1 times 1 times 1 is 1. So I'm using my difference formula, a minus b. Now I got to be careful here. A squared is 2x times 2x, or 4x squared, plus ab plus b squared. So I know that these are new, and I know that this is a little bit